Okay, the object of today's exercise is to give my lovely Daisy Red Ryder an upgrade. Now, as you know, I've already done some mods to my Red Ryder. It's got a custom buttstock and a custom forestock, and it's got an adjustable 4-windage rear sight. However, like all modern Daisy Red Ryders, this one doesn't produce anything like the amount of power that Daisy claim for them. According to Daisy, and it's written on the box that the gun comes in, that these should produce 350 feet per second. Well, they don't. Best I've seen out of mine is about 280. However, there are some upgrades that you can do to the Red Ryder to improve this. Now, the first one, most obvious one, is to replace the mainspring. And there is a superb mainspring called a Cobalt 327 mainspring. Unfortunately, these are made in America, and they're almost impossible to get in the UK. So for the time being, that one is out until I can find an alternative. The other upgrade is to overbore the air tube, and that's what we're going to attempt to do today. Now, in order to overbore the air tube, we've got to get the air tube out of the gun, which means that we have to disassemble it. Now, I'm not going to video this because Shane Bruce over on his channel on YouTube, which is RestOModDaisy, recently did an excellent video showing exactly how to strip down a Red Ryder, and his video will be far better than anything I can do. So I'll put a link in the description so that you can see how to do it. But it is a fairly simple process, providing you've got the right tools. So I'll get it stripped down, at least get the spring assembly out, and we'll take it from there. Following Shane Bruce's instructions to the letter, which makes it very easy, and using my own homemade spring compressor tool there, I've disassembled the Red Ryder into its component parts, and this is the part we're now interested in, which is the spring assembly. So I'll close in on that. So this is the spring assembly, and this is the air tube. This is the bit that we're interested in, and this is the bit that we're going to bore out. But before we can do that, we have to remove it from the spring assembly, and we have to pull it out from, this is the compression cup, this rubber bit here, and it just pulls out from there. But you've got to remove it from this. So that means compressing the spring and removing this little tiny pin, which you can just about see there. And I'll show you how we're going to do that. Now, in the past, I've used my drill press to compress the spring and remove the pin and extract the compression cup and air tube. But watching Shane Bruce's videos on his YouTube channel, RestOModDaisy, he had a compressor for Daisy springs which he made out of a cork gun, and it's very, very simple. And I thought, right, well, I'll make one of those because it's going to make life a lot easier. Basically, it's a cork gun. It's got a piece of wood screw to the plunger cap with a milled out slot in it to take the end of the Daisy spring assembly. It has a bit of wood bolted to the bottom so I can hold it in the vise, and then this bit slips over the spring assembly so that you can actually compress the spring and remove that pin. So I will show you how that works because it just makes life so much simpler. So this is the setup. Basically, you've got the spring assembly fixed into the cork gun like this. This plate basically slides across the center tube, and the spring butts up against it, and we want to release the pressure on that little tiny pin there. So basically you just give it a couple of squeezes like that, and that's all there is to it. And then you can just push this pin out or pull it out. There we go. And then the air tube and the felt washer, the oily washer, pull off, and there's the pin. And basically that's it. That's all there is to it. I'll take that off, and then I can release this. There we go. Now at this point you could take this out and you would fit the new spring, but I'm just going to leave it in there because I haven't got a spring to fit, so I'm going to use that spring. So we'll just leave it in there for now. Now the air tube should just pull out of the compression cup. It's not particularly, it's only held in there by the rubber, so yeah, so there we go. It's important to note that the pin has a flat on two sides, so you need to know which way that goes in when you put it back. And there we go. So that is the air tube. That is the object of today's adventure. We're going to stick this in a collet in the lathe, and we're going to very carefully bore that out to 7/64. So that's the next operation. So this is the setup I've got on the lathe. I have both the air tube and the 7/64 drill bit held in collets on headstock, and we're going to run the lathe very slowly. These are stainless steel apparently, these air tubes, so the cutting speed for stainless steel is very, very low. I think it's something like 50 surface feet per minute, so you don't want to run it too fast. And I'm going to do it very slowly because obviously the flutes on a tiny little drill like this are going to get blocked up fairly quickly. So yeah, I'll zoom in on it and you can have a look and see how we're gonna go. Get some lubrication on that. Yeah, it's cutting nicely. Running the lathe at about 400 RPM. Well, that's nice. They're coming out nice now. The swarf. That's exactly what I'd like to see. That's lovely. Let's bring it out, clear it off a bit. Now, obviously, this is going to take some time because I've got to come all the way down to this blue mark here on the drill. So take it very slow, very steady. I'll bring it back when I'm done. Well, I'm pleased to report that it was a successful operation. I must emphasise though that you do have to take it slowly. I was literally initially drilling about 1/4 of an inch in length, pulling it out, cleaning the swarf off, putting some more cutting oil on. When I got near this end, so the vast majority of the drill was inside the air tube, I was literally nibbling away, taking about 1/8 of an inch cut in length, pulling it out, cleaning the swarf off. And if you feel the drill catch at all, then pull it out immediately, clean it off, put more cutting oil on it, and yeah, take it slow and steady, and yeah, it worked fine. I don't know well you can see the end of it, but there you go. That's your overboard air tube, 7/64 all the way down now. So all I've got to do now is reassemble it, which is exactly the reverse of disassembling it, so I'm not going to bother filming that. Well, what we'll do is bring you back when it's done, and we'll put it over the chronograph and compare it to the results I got from it when it was standard. Just before I put it back together, I can't stress enough how important it is to make yourself these couple of tools. This compressor and this compressor, they just make your life so much easier if you're working on daisies. This thing particularly is an absolute doddle to use, and it's way easier than what I was doing before using the drill press. So yeah, the cork gun cost me £8 in the UK. I'm sure they're probably a lot cheaper than that in the States, but it was a worthwhile investment to make this, because it just makes life easier. And this didn't cost me anything. That's an old bit of a broom handle and a couple of bits of mild steel rod, so you know, there you go. Right, I'll get it back together and we'll see if we can get some improved results. My Daisy Red Ryder is all back together with its new overboard air tube, and we're ready to do some tests. I've got my cheap Chinese chronograph ready, I've got my support blocks ready, so let's put a few BBs through the chronograph. Well, I don't know whether you can see that, but that's the very first one through the chronograph. Bearing in mind 280 was the maximum I got before, now that's 318. So we'll do some more and we'll take an average. Bit lower this time, 313. $315, excellent. $313.9. $312.3. Right, I'll go away and work out an average, and we'll come back and compare. So here's the results. Before, the average was 274.5, maximum I got was 280. I've not really seen anything more than that with the standard air tube. Much higher results with the 7/64 overboard air tube, average coming out at 314.4, which gives an overall average increase of 39.9 FPS. Let's call it 40 FPS. Now 40 FPS is well worth having in my book for the relatively simple operation of just overboring the air tube to 7/64 of an inch. So there we go, that's it. That was the whole process of overboring the Red Ryder standard air tube to 7/64 of an inch. Now I think it was well worth doing. We've got roughly a 40 FPS increase on the output, which is great. Now obviously I'd love to fit a more powerful spring, but as I said, the Cobalt 327 mainsprings are impossible to get hold of over here in the UK. However, when I had it apart, I did measure the dimensions of the standard spring, so I can have a look to see if I can find something that is maybe just exactly the same overall dimensions, just a little bit longer, which will give us just a little bit more power output, hopefully. Anyway, that's it for the Daisy Red Ryder upgrade. As always, hope you've enjoyed the video, and thanks very much for watching. Cheers.